Hello, this is Group 11. This is Favyan, Torres, Chris Rengifo, and Robert Esperon. Our topic is high-speed rails. High-speed rails is a method of transportation that operates significantly faster than traditional trains because they travel up to 150 miles per hour. These high-speed rails are beneficial to our society because they create more jobs and reduce our carbon footprint. The first high-speed rail was developed in Tokyo that connected Tokyo to Osaka just in time for the 1964 Olympics. Early development began in Germany in 1899, where the Prussian State Railway joined with electrical engineering firms to create this technology. Shinkansen translates to a new trunk line in Japanese. Shinkansen is a network of high-speed railways in Japan. These lines today are amongst the busiest high-speed rails line. Traditionally, travel from Tokyo to Osaka takes around 6 hours without high-speed train. Now with this technology, travel takes up to just below 4 hours. Now after the initial infrastructure from Tokyo to Osaka, the Shinkansen expanded westward to Hiroshima in Fukaku, which was completed in 1975.
There are two types of high-speed trains. The first type that I'm going to talk about is the traditional type, which uses the same rail systems and a wheel on the rails to be able to propel itself. Now the difference between this and a regular train is the electric motors that are able to produce the speed necessary to be considered a high-speed train. The types of tracks that are used in this system is a continuous welded track for more comfort and misalignments and to reduce the misalignments and vibrations. Now these trains also have a special motor that is used for distributing the forces, which allows for a more comfortable ride for all passengers and the engineer. Now the second type is the maglev, which is more for, it's a magnetic levitation train. These maglevs get their power from an electric coil that is under, and it produces a magnetic field just as if there was two magnets going together or repelling each other. These maglevs are basically in Japan. Japan was the first one to incorporate this magnetic field train, and it uses, like I said, it uses the magnetic field to propel itself and decelerate with a special braking system. And also it has its main focal points are that it generates high speeds when it's necessary and its high separations.
Alright, I'll be talking about the possible future developments in the railway systems. First we have the California high-speed system. Now the California high-speed system is supposed to connect major regions in California. The future plan is to develop a high-speed system that will connect San Francisco with Los Angeles by the year 2029, as well as eventually link up Sacramento and San Diego. The next one we have is the Florida high-speed system. It's privately owned by a company known as Allboard Florida, and its purpose is to implement a new system that will connect Miami to Orlando with rest stops in West Palm Beach and Fort Lauderdale. Now this system will acquire a high rail system that will reach top speeds of 125 miles an hour. Now the Texas high-speed system is owned by a company known as Texas Central Railway. It took the liberty and design to build a system from Houston and Dallas. Now typically the drive from Houston to Dallas is roughly 4 hours. Now this system will cut that time from 4 hours to 90 minutes. And it will consist of bullet trains. Now bullet trains, as specified earlier, is a high-speed system that will reach a top speed of roughly around 200 miles an hour. Next, we have the Sweden high-speed system, and the Sweden high-speed system is going to be created by a company in Sweden known as ABB, and with $200 million funds, they will retrofit the system that they have now to railway system, a high-speed system. And then in conclusion, high-speed systems are a method of transportation that will help us and remove the carbon footprint in the world. It will help us develop job employment.